Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. Deep learning as an approach, and specifically the transformer architecture, seems like a winning combination for a variety of seemingly unrelated tasks. Every thought leader of industry should be asking, how might I deploy the transformer for my business? And I think even creative people should be asking themselves, how might I deploy the transformer in my creative effort? That's why I was thrilled to come across an excellent review titled Music Composition with Deep Learning. Today's interview explores that paper, asking questions about the state of the art in applications of machine learning on music composition, and more than a few good ideas about what creativity is and how machines can contribute to it.
So I am Carlos Hernández Oliván, and I'm a Ph.D. student at the University of Zaragoza. And my research interests are on artificial intelligence for audio and music applications. So I'm looking for building new models for symbolic music generation for helping composers in their composing process.
Well, I know the paper we're going to talk about is very much what's going on under the hood in that compositional process, but maybe to kick things off, I wanted to ask you, do you have a vision for what composition should look like maybe 5 or 10 years out? What does the tool set look like in the near future?
There's some very nice new tools for audio generation, for music generation from the audio. Now based on text prompts, I believe that there should be more DAWs, like digital audio workstations, redefine digital audio workstations for helping composers make music with new technologies. So not based on MIDI plugins, but also for using these new technologies to compose new music from symbolic or from the audio.
Well, I think most composers today would definitely be using a digital workstation of some kind. In theory, you could still write on staff paper at a piano, but even then, someone has to transcribe it. It must go in the computer. This is the modern era. Is that now a baseline? Will maybe some composers always go and do their own notes right on a score? Or do you think it'll be a full transition where the nature of composition evolves and everyone is doing it in a different way?
Well, I think maybe some composers would still like to write on the score. But yeah, generally I think with new technologies, and resources, maybe composers would use more new digital audio workstations, because you compose at the same time you listen. And that's, I think, very useful. We don't have always a digital audio workstation with us. We don't have a computer with us every day at every time. So for writing simple ideas, I think the score writing will be very useful too. Some hours a day, the working hours, we will use definitely the computer, I think.
Could you talk a little bit about the ways in which machine learning can contribute to composition? If I'm a composer, how do I use machine learning as a tool to help me?
Well, sometimes it's difficult for our composers to have new ideas. There's kind of block when composing music for example, movies, where the composer don't find the right ideas that he wants or she wants at that right specific moment. So I think maybe machine learning would speed up the process. Maybe give new ideas, maybe not the best ones at the beginning, but it can recommend new things faster, I think.
It is possible for someone with some basic programming abilities to write a random music generator. I'm even told I think it was Bach or Mozart had some sort of dice game that could randomly generate melodies. But I think these random melodies, they sound not so good, probably most of the time. What advantage can machine learning have over the dice game?
Yeah, I think what machine learning can do is generalize and can understand little bit the genre of music era. And yes, even if the generation is not perfect, it can output some stylish music. So I think that could help for people that maybe also I see music generation as an educational tool. So also it's helpful to maybe have a generator for new for people who are studying music composition.
Well, deep learning is a relatively recent phenomenon if we look, in the entirety of human history. So music with deep learning has to be new as well. Do you have a sense of what the, short history of scholarship is? What sort of things have been studied?
Yeah, so from the past, some researchers started with Markov chains, some data-driven technologies. Now, with the advent of deep learning, seems like everyone is using deep learning because it allows to generalize more complex data. So I think we are going towards building some models that can generalize about lots of music genres. So maybe we started building technologies that with kind of rules, like I know the scale, write a melody that has to follow these rules because as a composer, researcher, I know how music is built in sections, harmony, and I can write the rules. So with deep learning, we don't need to write we don't need to write those rules in the code, but the model can learn them. So I think it's a big step towards new models that can generalize.
In order for music to be something machine learning can look at, we have to express it as data. So music can become data in a variety of ways. There's MIDI files, there's the music XML format, or maybe even something higher level like you were describing that talks about the chord structure and changes and things like this. In what way do you represent the data?
For symbolic music generation, fortunately, we have some information that we don't have if we want to generate from audio. But even that information only contains note information, where the note starts, ends, and the value in frequency or pitch of the note. But for more complex generation or even for analyzing, we need tools that analyze this music and tell us this is a C minor chord, or this is this scale, or we are in the section A, or in a cadence for Western symbolic music. We normally use music XML and MIDI files, but if we want to condition models for symbolic music generation, we also need some pre-trained models or algorithms that analyze that music for us and tell us the harmony or the sections, or more information about the music that can't be found in MIDI files or music XML files.
And can you say a few things about the methodologies used? To say using deep learning could mean one of 100, maybe 1,000 things anymore. What are some of the architectures or techniques deployed?
Nowadays, I feel most of people is using the transformer. There have been many great works that produce good results with the transformer. Also, there are some new works with generative models. One of the first ones with generative adversarial networks, MuseGAN. But I think we are going towards the transformer architecture, to build transformer models that can generate more tokens, that means more music, and that can be conditioned on different music parameters like harmony or structure, for example. Also, it allows to continue given melody or composing an accompaniment for a given melody too. So I feel like even if generative models are there and are quite new, nowadays the transformer is one of the most used architectures.
Yeah, Transformers had so many successes in so many areas. If I were a gambling man, I would definitely bet on the Transformer. But it's not a foregone conclusion it will work in every domain. Did you have any ideas about what about the Transformer would make it especially good for music?
Why a transformer worked well with music is because we have the MIDI file of the music, or the music SML file, and then we convert that file in text. So in tokens, like words. So where a note starts and note on is a word for us, when the pitch is another word. So we build a vocabulary and we adapt the MIDI file to a text that can be input to a transformer. I don't know, or I don't feel if that is the best way making music, because music is not like plain text, because we have very variables like harmony and so on that text, that's a plain text doesn't have. But it worked, and there are some new studies about how to different kinds of ways of tokenizing or converting MIDI files into text to have a better output.
Well, in other domains, audio for one that I've seen, the recommendation seems to be to give the raw audio to deep learning, and rather than trying to maybe make your own custom phoneme detector and give it the phonemes. So at least in that situation, there seems to be some advantage going end to end. In which case, you wouldn't necessarily want to express harmony. You would want to express the very low level MIDI events. I guess, do you have any thoughts on that point of view? What if I was a really end to end completionist and said, forget about music theory, let's just let the machine figure it out?
Yeah, I'm what happens. I think that having an end-to-end method is great, because that would mean that we build a model that understands music, and that's saying a lot, I think. But if we want to play with the model, let's say I want some kind of low-level conditioning, because not everyone has the same music knowledge to interact with a machine learning model. So I believe that for unexperienced composers, it would be okay to have an end-to-end model just to output something that sounds good. For very experienced composers, I feel they would like to customize the output. And to customize the output, or you either have a good plugins or a good digital audio workstation, or if you want to do it in the model, maybe you will have to build a model that can be conditioned on these low level features.
Well, I've done a little work with MIDI files, and one thing I've noticed is that a good MIDI file, the notes also have a velocity where they've sort of captured the pressure with which the instrument was pressed. So, sort of the true expression and detail of the piece. Other MIDI files, it's like someone just click, 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 put the notes in there and they're all flat. I have no velocity volume data. Does that pose a challenge for your work?
Yeah, so when we have a data set, the most important thing is before we start working is deciding, yeah, the data set and pre-processing the data set and extracting some kind of metrics about the data set. So because, as I said, the deep learning model will output things that are similar or will learn from that. If we train a GPT with text that is not coherent, I expect that the output won't be coherent. So that same, I think, happens with music if we use transformers. But the velocity is only one more, let's say, feature or token or word that we can add to the representations. But there are lots of more that are not represented on MIDI files, like texture or playing techniques like staccato for strings. And that's very, very interesting from a point of view. In music XML, this information is kind of better represented than in MIDI, but still the pre-processing takes a lot of time, and it's very important to ensure that we are training with the correct data.
Well, even when we have a lot of markup, what notes are staccato, what the dynamics are, within that, as an instrumentalist, I find I have a certain amount of interpretability I get to how I do phrasing, for example, as a wind instrument. I'm even if it says forte, it's not I'm playing every note the same velocity. I'm making choices as a musician. Do you think that that choice will eventually go inside the model, or maybe there's a two-stage system like you described, we output a MIDI that has or doesn't have that, and then the audio rendering which perhaps introduces the decision. What sort of pipeline do you envision when it comes to that level of expression?
Yeah, well, I think it's always on the user that interacts with the model. If I don't know anything about music and my level when playing music is not really good because I am a beginner, maybe I would like some kind of first recommendation with some dynamics that I could follow or some playing techniques. If I am a beginner composer, it also helps, I think, having some marks on the playing technique because it really changes the way of playing and it changes the expressivity and everything if according to the playing technique and the dynamics. So so a model can output a melody without any dynamics or any playing technique written on it. And depending on how I play it, it would change completely the output. So I think we can have both kind of models, simpler models that have only the information of the notes, and I can produce very good melodies that they can be rearranged. Or if we are going towards an end-to-end a complete or generalized end-to-end model, it would be fine to also let the model decide uh, what kind of dynamics or playing techniques, depending on instrument, it can yeah output.
And could you speak to the data sets you have available? What can you train, or how can you get music on which to train the models?
There are some available datasets for symbolic music generation, like the LAC-MIDI dataset, that has been used in lots of research works and has been also, I think, is the dataset that most works use as for bass lines. There are other datasets for only piano, like the Maestro dataset, that is also available in audio format. Unfortunately, I think there should be even more datasets because not the we have some datasets, but we don't have enough, in my opinion. So we have classical music, pop music, rock music, but I believe music is has a wide more range than those genres, and there are not lots of open source datasets for those genres that are not classical piano or rock or pop. But fortunately, too, we have some kind of dataset that we can train our models with that are used mostly on research, like LAC-MIDI dataset.
Well, when we evaluate machine learning algorithms, we can look at things like the accuracy and the F1 score and these sort of traditional statistical metrics. And I'm sure those still apply here. We can ask how faithfully your model can reproduce things like its training data set. But it seems like maybe there's something missing here, like the quality or the enjoyment or the emotion it gives me. I don't know of any machine learning metric that can measure emotion, for example. Are there auxiliary things that you look at for evaluation?
Yeah, normally there are two kinds of evaluation. The objective, which gives us numbers to compare this model is better than another one, and subjective evaluation. What happens with objective evaluation is that it's very difficult to rate with a number how music is. If I would ask what is the music quality from 1 to 10 of one piece of music, we would have maybe a wide range of answers if we ask some users, because not everyone likes the same kind of music. We have different tastes and experience with music, so it's very difficult to give a number. So some kind of objective evaluating metrics have been developed to try to measure or compare the generation, However, I think there's still a lot of room of improvement in evaluation, in music evaluation. And what happens with subjective tests is very similar, because if we ask a certain group of users, we have to be aware of their music knowledge and preparation in knowledge of music, because, as I said, it's trivial to rate random notes in a score, but when it comes to more complex generation, it's hard to rate music. So I think also subjective evaluation should be improved, but I feel this is a very difficult path, because there is it's not reproducible, because if we write a paper on a model and we write another paper on other model, the users will be different. We will ask different people. So it's difficult to measure the quality of music. So I think there is a lot of room of improvement here.
Well, when I think about the human process of learning to compose, I think the earliest compositions, maybe creativity isn't so important just yet. It's thinking about really following the rules, making sure it's not discordant, and I follow similar, well-known progressions. Don't go outside the box too much because you need to learn the process. I would not be surprised to learn that machine learning is very good at producing introductory level, simple first pieces like this that are suitable. Do you find that deep learning can go beyond this and introduce new flourishes and new ideas that one would regard as creative?
Yeah, I think there's I think unsolved question, that is if deep learning is creative or not, if it can produce new art, because I think what makes a new art is also the experience of people with that over the years. And I think deep learning has not reached yet that level. If it will reach that level, I think somehow could be possible. I don't know if soon or later, maybe not soon, because what seems now is that deep learning interpolates in the somehow in the training data. However, interpolating, if it's well done, can be understood as a new art, new ideas. So it's interesting how deep learning will be able to also, by interpolating, creating new ideas. And I think, looking at Western classical music, the most important parts of, well, or in my opinion, what defines this creativity is very small and short segments of music, the motifs. And what happens with deep learning is that for now, the models can generate music, but they don't realize if they are writing a motif and they are writing a development of that idea. So they are just outputting stuff. A composer knows what the motive is, and they develop from that simple idea. So I think there are very different ways of composing between humans and deep learning, but that doesn't mean that deep learning wouldn't be able to compose new styles or new ideas.
Well, when you follow the history of large language models, you can often find these visualizations people have made where they describe how big the models are. And of course, the BERT model from many years ago is this tiny little pebble versus GPT-3 is this humongous boulder because it has so many more parameters and a much larger training data set as well. Do you find we're on a similar curve with music modeling? Will we get added benefits from bigger and bigger data sets and more parameters? And if so, where are we on the path from pebble to boulder?
It's very interesting, the comparison between music and text. I feel, for example, GPT-2, 3 is trained with lots of tokens, but we don't have that huge data sets for music. Even there's a lot of music pieces, it's difficult to find MIDI files for all existing music, and also MIDI files which we can work with, because they must be well written. Also with music SML, the pre-processing needed is also quite huge. So I think, yeah, if we have enough data, we could build bigger and bigger models, as I think in the audio domain is happening with these new models, audio LM, music LM, and so on.
Well, in terms of the composition, I mean, you can have a solo composition, right? A single instrument playing, but most music that people like to hear, there are multi instruments or at least multi voices on something like a piano. Is the approach to output the composition measure by measure or instrument by instrument?
Yeah, that depends on the way you convert the MIDI or music SML files to text, to tokens. There are some token representations that are bar to bar, so they process one instrument and all the bars of that instrument, and then they process the next instrument and then all the bars of that instrument. Other representations take bar to bar for all the instruments at the same time. So it depends a bit on the pre-processing step.
This is an area where I wonder if music theorists might be quite opinionated about the technique that at least the human would follow in writing parts. Do you think there's an opportunity for a collaboration here that we could take ideas from music theory and build a special multi-head attention something or other and see an added benefit from a music-specific architecture?
Yeah, definitely. I think there should be more collaborations between composers and researchers on music generation, because yeah, if we train a transformer with a simple attention system, it will output some things, but what good models for music generation do is try to redefine this attention model to focus on important information, like the music transformer or museformer. So they try to modify this attention model to focus on notes that might be important. When I talked about the motif in Western classical music, I really like the motif generation, because it's where all the ideas are that then are developed. So maybe building with composers an attention model that focus on the model, on the motif, would be a very very nice and insightful idea, because sometimes the transformer, what happens is that it can generate 30 seconds of music, but it ends up forgetting what's the motive. So I think if we could ask the composers and also with research engineers how to focus on and not forget the very early motive on the piece, that would be, I think, that could lead to big improvements, I think.
Well, I want to ask you about the state of the art in assisted composition and maybe something like a Turing test. But I want to remind the listeners about a key area. Maybe you already know it with the Turing test. It's not that I would be a little bit tricked. Like, let's say I went into an elevator on the way to an appointment, and when I arrive at the appointment, they say, "Oh, by the way, the music in the elevator was computer generated. Could you tell?" What I wasn't paying attention. The same is true of the Turing test. It's not that you accidentally talked to a bot, it's that you were testing the bot. If I really got in the elevator to test my skill set, do I think this is human music or computer music? Would I be fooled by the state of the art?
I think in symbolic music generation with a good synthesis and post processing, I think so. For audio generation, I'm not very, very familiar with it, but if the music is not very, if it doesn't last long, just few seconds, I think it could also fool us. Yeah. In symbolic music, I think it's easier to fool people because there's more research on it through the years, and it needs a post processing, so you can play with the effects and so on, not with or not yet with audio generation.
What are some of the open questions then that people like yourself look into?
Yeah, I think one of the open questions is if music generated by deep learning would be creative. More technically, are what what's the model size I need to train to generate at least coherent music, because not everyone has the resources to train a GPT or something like that. Another thing is the data set, because as I told before, there are some open source data set, but not for every music genre. Some of the questions are related to, yeah, the model size. If I have this number of files, would the generation be okay if I use a transformer, a baseline transformer with a basic attention system? Will it follow a genre or a structure? But I think the big question is if at the end these models could be creative and could help not only, let's say, basic users, understanding basic as not with a strong knowledge or strong knowledge about music theory, but also professional composers.
Well, I'd like to ask you one prediction about the future, which is always a little unfair because how could we know? But I like the idea that in the world we live in, a talented musician could make it their profession. Do you think some of these AI technologies are a threat to that world?
I think not really. If the professional musician is have a strong knowledge and is a really professional musicians, I think human orchestra can't be substitute even for very good plugins. I think human always is different when listen to recordings. Also happens, I think, with composition. So I think more about music generation with the deep learning to a tool to assist composers and not something to substitute them.
Well, very good. I like that vision a lot. And Carlos, what's next for you?
Yeah, so I would like to continue working on music generation, especially symbolic, and maybe if I can, relate it to also emotions, for example. That I think is a very important part, but it's also some challenging because we don't even feel the same for the same emotion. We don't feel the same things. So I think also music generation could be benefit from understanding how humans feel and also generating music through emotions.
And is there anywhere listeners can follow you online?
Twitter. I am, well, not very active in Twitter, but I look for some research there. The research community is very active on Twitter, so I'm there as Carlos Heroliv.
Cool. We'll have a link in the show notes for listeners to follow up. Carlos, thank you so much for taking the time to come on and share your work.
Thank you for you.